Today we're looking at 7.5 special systems or special types of linear systems. It begins on page 426 in the textbook. We're identifying systems having one solution, no solutions, or infinitely many solutions. These being said, there will be parallel lines, lines that intersect, or lines that have exact same equations. Example number 1 says show that the linear system has no solution. Okay, we know if it's going to have no solution, that means it's going to be parallel lines. There's a graph that's done for us already, just to help us to make sure that we put the graphs in the correct spot and we can see that they're parallel lines. But algebraically, without having to show the picture, we can determine that they're parallel lines, meaning they have no solution, by checking out to see what the slope is. So method number 1 says graphing, rewrite each equation in slope-intercept form. If you look at the first equation, or both of these, I should say, they're in standard form, ax plus by equals c. We want to move, just like the bell work, we want to move negative x over to the other side, and it leaves you with y equals, because you don't do anything to change y, negative x becomes positive x, and negative 3 stays just like it is. So that first equation should be y equals x minus 3, mx plus b, where your m value is 1, and your b value is negative 3. When you move the other equation, again, you're going to move negative x over, and you're going to have y equals negative x becomes positive when it moves over, and it stays positive 2. Again, where your m value is 1. Just right here, you can see that both of their m values are 1. They're going to be parallel lines, and they're not going to intersect each other, which means there's going to be no value that's the same. And that's the same thing we have written here in these blanks they prepare for you. Okay. It says because the lines have the same slope but different y-intercepts. Remember, that was the second part that was key about them being parallel lines. Different y-intercepts, meaning they cross through in different spots. They're parallel, and they'll never have any intersecting point. Therefore, there'll be no solution. The second method is the substitution method. That was graphing, and that was the first method we learned to solve systems. The second one is the substitution method. It says since equation 2, but both of the equations can be written in y equals mx plus b, because that's what we did a second ago. But it says since equation number 2 can be rewritten as y equals x plus 2, then that means you can substitute this value x plus 2 in place of y. So in equation number 1, which says negative x plus y equals negative 3, in place of where it says plus y, we're going to plug in x plus 2. And it's going to say negative x plus 2 equals negative 3. Again, substituting in that value x plus y. Then when you combine your like terms, when you combine negative x and positive x, they cancel each other out. And they leave you with a statement that says 2 equals negative 3. We can look and check its truth value of this part of this equation. It is not true. 2 is not equal to negative 3, therefore it's false. And when you get a false statement, then there'll be no solution. Anytime you eliminate all of the variables, regardless if you try to or not, using the elimination method of substitution, if it gives you a false statement at the end, there's going to be no solution. Okay, in the margin on the back where they have all that white space, copy this one down real quick. It says show that this linear system has no solution. Give you about a minute. Do it just like example number 1. Again, it says show that there's no solution. The way you do that is you show that the lines are parallel. Parallel lines will not intersect at any point, so there'll be no solution to the system. The only way to determine these lines are parallel is to graph them or to show that they have the same slope. That was the two different methods that we looked at for example number one. Showing the same slope is probably the shorter version, so that's the way we're going to go about it. If we take this first equation, negative 6x plus 2y equals negative 8, if we want to see what its slope is, we're going to put it in slope-intercept form, which means we're going to undo negative 6x by moving it over. It's going to become positive 6x. So 2y is going to stay on the left side just like that. Negative 6x again becomes positive 6x. And negative 8 stays by itself. Again, you can't put those two together because they're not like terms. Then get rid of 2 times something by dividing by 2. Do it there and there as well. So you have y equals 6 divided by 2 is 3x. Negative 8 divided by 2 is minus 4. The only thing you're interested in, or the first thing you're interested in, I should say, is the m value 3. The negative 4 is going to come into play when you determine if they both have the same slope and different y-intercepts. But let's just look at the m value 3 for a second. Compare it to the slope value of the other equation, negative 3x plus y equals 7. This one's just a one-step equation. Move negative 3x over and it becomes y equals positive 3x, positive 7 or plus 7. Again, showing what the m value is. It's the same value 3. That means they're possibly parallel lines. The other part you have to check is see if they have different y-intercepts. And they do. That makes them parallel lines. Had they had the same y-intercept, it would be infinitely many solutions, which we'll look at in just a second. Here's example number 2. This is one with infinitely many solutions. 3x plus y equals negative 1. Negative 6x minus 2y equals 2. So we have to graph them. In order to graph these, write them in slope-intercept form. So this one says 3x plus y, move 3x over. Y equals, it becomes negative 3x on this side, and it says negative 1 already. That says mx plus b. The other equation, move negative 6x over, it becomes positive 6x, but now we have negative 2y equals positive 6x, and it says plus 2 or positive 2. Last step, you have to divide by negative 2 here and here as well. Y equals 6 divided by negative 2 is negative 3x, and 2 divided by negative 1 is negative 1. Compare what the equations look like without even graphing them. We're going to graph them in a second. But notice they're the exact same equation. And you can see that that's what's written in these two blanks right here, negative 3x minus 1. It says from these you can see that the equation represents the same line. If you graphed it, you would just graph it right on top of the other one. Therefore, every point on the line is a solution. They're not parallel lines. They share every single point on that line and all of the points in between the ones I just highlighted. Method number 2 says you can multiply equation 1 by 2 in order to make linear combinations. Remember, 4 linear combinations, this is what we talked about Monday and yesterday. 4 linear combinations, you want one of your sets of coefficients to be opposite. So equation number 1 had 1x plus y. Let's look back at the equation real quick. I forgot what it says. 3x plus y equals negative 1. When you multiply that equation 3x plus y equals negative 1, that was the original one. When you multiply all of those terms by 2, you have what they have written here. 2 times 3x is 6x, 2 times y is 2y, and 2 times negative 1 is negative 2. In essence, you create opposite x values, 6 and negative 6. And what that does is that allows you to eliminate your x's. So then you have 2y equals 2. Or when you combine, not 2y, I'm sorry, when you combine the next set, that was your x's. When you combine negative 2 and positive 2, notice those eliminate as well. Those eliminate as well. And when you combine negative 2 and positive 2, those eliminate as well. So everything winds up eliminating, and you get a statement with no variables in it. 0 equals 0. Then, just like on the last one, check its truth value and see if it's right. 0 is equal to 0. Unlike the last one where it gave us a false statement, notice it says 2 equals negative 3. That's false. None of them are going to be true. That makes parallel lines. This one gives us a true statement. That means any version or any values you plug in are going to give us a positive statement, any ones that fall on a line itself. So it says the variables are eliminated, all of them, we got rid of them, and you're left with a true statement, which means infinitely many solutions. It means there's an unlimited amount of solutions. Copy this one down. To show that the linear system has infinitely many solutions. Again, all you're trying to do with this one is prove they're the same equation. If they're the exact same equation, then it'll just graph on top of this. It'll share every point. All right, let's take a look at these. We're trying to look and see if they're the same equation. If you look at that first one, if you multiply it by negative 3, you'll notice it turns into the second one. But in case you can't see that, let's move them to where we can see it. Move negative x over, it becomes 2y equals positive x minus 2. And divide by 2. Divide here and here by 2 as well. Y equals 1 over 2x minus 1. Slope-intercept form. Let's check and see if the other equation becomes that. Move positive 3x over. We still have negative 6y. It becomes negative 3x, and it's still positive 6. Divide by negative 6. Y equals negative divided by negative is a positive 3 over 6, which reduces to 1 over 2x. And then 6 divided by negative 6 is minus 1. Notice the equations are exactly the same. Yes, they have the same slope to make them parallel lines, but they also have the same y-intercept of negative 1. And that makes them infinitely many solutions. Let's check the checkpoint 1, 2, and 3. Okay, we have x minus 2y equals 3. It says use the substitution or combination method to tell how many solutions it has. Remember, it's either going to have one solution, no solution, or infinitely many solutions. So move this x over, it becomes negative 2y equals negative x plus 3. Divide by negative 2 on all terms. And y equals positive 1 over 2x minus 3 over 2. There's mx plus b. Do the same with the second equation. Move negative 5x over. It becomes 10y equals positive 5x. They still have negative 15 on the right. Divide by 10 on all the terms. And y equals 5 over 10, which simplifies to 1 over 2x. And then you have negative, since a negative divided by a positive is a negative, 15 over 10. 5 goes into both. It goes into 15 3 times and into 10 twice. Notice the equations are exactly the same. You couldn't see them when they were in standard form, but in slope-intercept form, they come out to be exactly the same. If they're exactly the same, they have infinitely many solutions. So the answer is infinitely many. Let's look at number 2 real quick. Move them both over. Negative 2x becomes 3y equals positive 2x plus 4. Divide by 3 on both sides. Y equals 2 over 3x plus 4 over 3. You have to divide both terms. Do the same with the other equation. Move negative 4x over, it becomes 6y equals positive 4x plus 10. Divide by 6 on both sides, y equals 4 divided by 6, which is going to be 2 divided by 3x. And then 10 divided by 6 will be 10 over 6, which is plus 5 over 3. Notice these have the exact same slope. So we have two equations, y equals 2/3 x plus 4 over 3, and y equals 2/3 x plus 5 over 3. Notice the slopes on both of them are 2/3. If they have the same slopes, remember parallel lines have the same slopes, but they have different y-intercepts. Their b values are different. That means these lines will never cross since they're parallel. So the answer is no solution for this one. Number 3 says negative 25x plus 15y equals 2, 5x minus 3y equals 7. In order to see both of these, put them in the slope-intercept form where you can see them. If you take that first equation and you move negative 25x over, it leaves you with 15y equals positive 25x. Remember, it switches signs. 2 doesn't move, so it stays as positive 2. Get rid of 15 times something by dividing by 15. Do it by this one and this one as well. Y equals, a positive divided by positive is going to stay just like that, but the number 5 goes into 25 5 times, and it goes into 15 3 times. So 5 over 3x plus 2 over 15. That's slope-intercept form right there. Let's see the second equation, see how it works out. When you move 5x over, it leaves you with negative 3y equals, 5x becomes negative 5x, positive 7 stays the same. When you divide by negative 3 on both sides, you got to do everything by negative 3. Y equals positive 5 over 3x. And then positive 3 divided by negative 3 is, we can just put the negative on top and say negative 7 over 3. So compare the slopes of both of these. Your slope of the first equation is 5 over 3. Your slope of your second equation is 5 over 3. So they have the same slope. So these are potentially parallel lines. The second part, those values are the same. The second part you check is, are the y-intercepts the same? If they were the same, then it would be infinitely many solutions. These are different, so that means these lines will never cross. So if you're picking between no solution, infinitely many solutions, or one solution, these will never cross. Therefore, there is no solution to this equation. They are parallel lines. Number 4 says x plus y equals negative 16, 11x minus y equals 42. When you move x over, you get y equals negative x. Remember, when it switches sides, it changes signs. Negative x minus 6. The other equation, when you move your x value over, 11x becomes negative 11. So y stays as negative because that's what's there right now. Negative y equals negative 11x, positive 42. That one doesn't move. You have to divide by negative 1. Divide that and that by negative 1. Y equals positive 11 because the negative divided by negative is a positive 11x. And then 42 divided by negative 1 is minus 42. When you look at your slopes of these two equations, this slope right here is negative 1. This slope right here is 11. So this number 4, unlike 1, 2, and 3, number 4 is not a special type of system. It is a normal system. So that being said, it asks you to find what is the solution. You have to use the combination method or the substitution method. Believe it or not, this one actually lends itself better for the substitution method because x plus y equals negative 6 can be easily rewritten if you move x over like we did a second ago as y equals negative x minus 6. You can take that value, negative x minus 6, and you could plug it into the other equation. The other equation says 11x minus y's value, which our new y value is negative x minus 6, equals 42. So when you distribute negative 1 to both of these, you get positive x and you get plus 6. So 11x plus x, since it's positive, equals 42. When you combine your like terms, 11 and 1x right here, and I'm going to jump all the way up to the top up here, You get 12x plus 6 equals 42. When you subtract 6 on both sides, you get 12x equals 36. You get 12x equals 36, and when you divide by 12 on both sides, you get x equals 3. So now you have a value for x is 3. You need to plug it back into one of the equations. This was the easiest equation, x plus y. So x's value is 3 plus y equals negative 6. Get rid of plus 3 by subtracting it on both sides. And y equals negative 9. I know I made a big mess all over the place. But x comma y, 3 comma negative 9. There's one solution. This is the one you had to do the most work on. Because once you determine that there was a solution, unlike numbers 1, 2, and 3, you had to determine what its xy value was or what its coordinates were.